Hi, today we will be discussing about top 7 characteristics of microservices architecture. Uh, we all know microservices architecture is a modern approach for building applications. We can break them into smaller and self-contained services based on the domain-driven model. For each and every domain, we will come up with the smallest possible and scalable services, and we will create the endpoint services for particular components, right? So this is how we actually build a microservices architecture. Microservices architecture is nothing but dividing the large functionality into smaller independent self-contained unit services, so that they will be independent, and we can use them as a self-contained services. We can also call them in any other service without any issues, right? So that way it will be loosely coupled system, and you can see some features here. They are self-contained, loosely coupled. We can also achieve scalability, flexibility, fault isolation, continuous deployment of integration. I'll explain the concepts, but you can see key takeaways before that. Microservices architecture are self-contained independent services. They are loosely coupled. They support scalability. Agility will be there. That is the significance of our thing. Independent services in microservice architecture allow for diverse technological choices. As I told you, some of these services we can develop in Java, some other service we can develop in Python, some other in Go language or any other language, .NET. You can develop with different services. And decentralized data management. We will have a separate database for service, right? We can also have it. We can actually denormalize the database and decentralize the data. Independent development, it will be there. So that way we can improve the adaptability and resiliency, and also effective inter-service communication, service discovery mechanisms are there. We can actually register all the services in a service discovery, so that they will be discovered, and we can establish the communication among the service to service, inter-service communication will be there. Microservices architecture, let me explain the architecture here. Basically, it is a modern approach to application development, offering significant contrast to monolithic and service-oriented architecture of the past. We know the monolithic application architecture is basically it will have model view controller. Everything we will write down, we will create, or we will develop at business layer, application layer. So it is a tightly coupled application. Service oriented architecture is also, we will have multiple services, and there will be workflow and orchestration. We will create them based on the workflow. The service oriented architecture will define the workflow structure. But the thing is, this dynamic framework empowers developers to create a self-contained. The microservice architecture benefit is, we will create a self-contained and loosely connected applications. Each component microservice is small and is focused service that excels at performing a specific function. Okay, forming a cohesive ecosystem and combined. So it is a very important thing, we have to note it down. Since they are self-contained, right? So they are also independent, they are also flexible, scalable. What is the scalable here? Let's say there are 10 services or 12 services. If any of these services failed, right, and immediately other services, they will not be affected, right? They will not be affected. And if I want to scale any other service based on some demand, and I can scale that. For example, most of the banking customers, they always look at the account details, right? They always verify the account details. For that, we can have account service. We can also have deposit service, withdrawal service, transaction service. But which service is going to affect most of this? Account service, because most of the people, they'll open the account and they'll see the account details, right? So for that, I can simply scale the account service. I don't need to scale all the services, right, in order to meet the demand. So that way scalability will be there and flexibility will be there. I can scale any service. If I want to do that, I can scale it, and if I want to scale down, I can scale down depending on the requirement, demand. Fault isolation is basically, let's say if any of the service failed, right, and other service will not break because of it, right? For that, we will implement fault isolation. So every service is independent. If any of the service among those services failed, and that will not impact or affect other services, it will not cause any issue or breakdown. So that way we can also implement fault tolerant service. We have a circuit breaker mechanism, fallback methods. We can implement all those using a microservices. Spring Boot features are there. But also you see here continuous and also other thing is fault isolation. If any service is down, immediately we can spin off other service also. It will be available, right? That way we can achieve this. You can see here and continuous deployment integration, right? Continuous deployment is nowadays DevOps mechanism is one of the best approach, because if it is a decentralized complex application, we may have a lot of multiple applications. So every time, every day we will get a lot of changes as per the agile process, agile methodology. So we need to deploy the changes immediately as soon as possible. So there should be continuously integrating process, continuously deploying process. So that is why using the developing services into deploying it would be very easy, right? So that way we can achieve it. Other thing is, these are all independent services. You see here, these are all independent services. There is no dependency of another service into. So everything is independent, right? So it would be very easy to maintain that service and to deploy the service. Decentralized management, since it is a decentralized management, there is no problem of losing the other data. The flexibility is there. We can also manage the database very easily. A developer friendly system management. So the thing is, you can see here, and also independent deployment. I can deploy any service I want to deploy, right? There is no dependency here. Let's say account service is there, withdrawal service is there. If any changes or any hotspot fixes happen, immediately what we can do, we can deploy the changes. That's why you can see in the production, immediately as soon as any production bug is fixed, immediately we move it to hotspot repository, and then we deploy that, right? Hotfix as part of the hotfix. So you see here, we can achieve all these things with the microservices architecture. Microservices architecture provides the flexibility and easy of developing and building an application. We can actually see the agility there. The agility, the flexibility, the scalability will be there. So all these things we can actually achieve. The ability to roll out new features to fix bugs in specific service swiftly and efficiently, accelerating delivery cycle, enhancing applications responsiveness to market demands. So we can see all these characteristic and benefits are there. You see the fault tolerance and resilience. As I told you, I can build resilience microservices. I can also establish the distributed monitoring and logging. Containerization is there. Service discovery mechanism, as I told you. API gateway. You can include all the cross-cutting scenarios into API gateway. Right, there is the first entry point service where you can actually configure the security and authentication and monitoring so many services. You can see nowadays establishing intercommunication is actually having a lot of we can actually build a lot of ways. You see here inter-service communication we can establish using REST or gRPC. This gRPC is the new technology. Recently Google invented it. So it is a way of communication which is very faster comparing with the REST service communication, which is why nowadays most of the companies they are using the gRPC service communication among the multiple services. This is a very robust and it is advanced. So it is very faster performance wise. It is very fast. That is why some of the companies they are using gRPC technology for establishing communication. You can also establish synchronous method, synchronous service using Kafka, RabbitMQ. some of the asynchronous softwares, or also active MQs. You can establish all these things. You can do that. So service discovery is nothing but, since there are multiple services, every service should be discovered by a particular name, right? So in order to discover the service dynamically, we need to have a service discovery component which actually ensures the services can locate and communicate with each other efficiently. So for that we need a service registry where we will register all these services, all the clients services to this service registry. That way, using the service discovery, all the clients that are registered to the service discovery, they can communicate and locate with each other, and they can communicate efficiently. And as I told you, API gateways are required where you actually configure all the cross-cutting scenarios, fault tolerance, resilience. As I told you, circuit breaker mechanism. You see, fault tolerance. What is the definition of the in interconnected web of microservice architecture? Resilience is the ability to withstand and recover from failures. As I told you, right, fault tolerance is embedded in the design, ensuring that the issue in one microservice does not cascade and bring down an entire service. So that is what I told you. If any service is down because of some other issue, something, immediately, so we will have some fallback methods, fallback mechanisms. Also, circuit breaker pattern is one of the, as I told you in the beginning of the video, circuit breaker pattern is one of the things where we actually provide fallback method, and we specify the circuit open, circuit close, and also and the time required to open circuit, close circuit. All these configurations will be there. We can configure that. And service monitoring and logging, one of the feature, because since this is a distributed architecture, right, we need to have a proper tracking of all the requests that can float throughout multiple RESTful web services. So for that we need to establish this communication, service monitoring, service logging is a very important thing. There are so many distributed logging mechanisms are there, monitoring mechanism. Spring Boot also provides an actuator concept to monitor health and metrics. Also we can integrate Zipkin and Sleuth frameworks to where we can see the spawn ID and request ID, trace ID for each and every request, and we can actually monitor the request flow. Containerization and orchestration is one of the best feature nowadays. Most of the companies, they are containerizing all the build artifacts into images, and then they are deploying them into image repository, so that they can simply download the image and they can deploy in any container, cluster or cloud, or most of the times we deploy them in Kubernetes clusters. So we can actually use the containerization concept. So why we need a containerization? Because as per the design wise, there will be flexibility of moving the images from one environment to another environment. You can move the container into on-premises server or cloud server, or or any other server. It is very easy. The moving the containers in between multiple cluster, different heterogeneous clusters is very easy if it is a containerized artifact. Okay, rather than a jar file, ER file, or WAR file. The benefits of microservices, as I told you, it brings many benefits. Among them, scalability is one of the benefit, and flexibility, cost efficiency. You can build resilient microservices. So basically, it is the flexibility to the developer and flexibility to the management also. For scalability also, you can scale them as much as the capacity is required based on it. There are also some challenges. I want to discuss some challenges here. Challenges, you can see adapting microservice architecture building potential. It is not without challenges. Some other challenges, ensuring data consistency across distributed system is a very complex task. If it is a distributed system, we can have many number of services. Establishing a data consistency is a kind of tedious task. We need to handle that at application service layer level, right? So that is one of the problem. And operational complexity of managing network of service can lead to challenges in network and management failure process. If there are thousands of services, it will be very complex for managing the network of services. We need to take care of that whole network, and that sometimes may lead to the network management and failure processes. Latency is also one of the problem. Even present aspect can emerge from the increased number of inter-service communication, potentially affecting the performance. The more is the number of services, definitely the more will be the communication latency. It will result some latency. So there are these challenges. But however, if we take care of these challenges, we can build very complex systems using microservices architecture, because it simplifies the developing the design of any application using microservices architecture. So that is why we for building microservice complex systems, complex applications, most of the team, they are still preferring microservices architecture. Thank you for the video. Thank you for listening.